Okay, good day, everyone. Hi, everyone, and welcome to another edition of Question Isolate from Mathematics Masterclass, which is an extension of Primary School Masterclass, the Caribbean's elite online educational academy. And these videos are for support and helping students, especially for exam type and past paper questions. Okay, so before I show you the question, let me first of all say that wisdom is the principal thing. Therefore, get wisdom, and in all thy getting, get understanding. So yes, Mathematics Masterclass adding to life, and we try to really bring the mathematics to life so it will be easier for students. So today's question isolate, we'll just be focusing on one particular question. Okay, and this question was posed to me, was sent to me from a student. The student actually sent it to me during the week, not during the support classes. We have support classes every Friday evening and Saturday morning. So students can log on and get their questions answered and also look at past paper type exams, even time management within an exam. So a lot of things are being done within these support classes. But there's also 24/7 support because, during exam time, when exam time comes up, things get a little bit busy. Students need help all the time. So we welcome that. So this student actually sent us a question and it was a little bit blurry, unfortunately. So you can see here, it says calculate the area of that should be the unshaded portion. So we have a shape here and that rectangular shape within another rectangular shape. And we need to find the unshaded area. Okay, so I took the liberty of recreating that question. And this is how it looks. It looks much clearer like this. As you can see here, the question says calculate the area of the shaded area, that being the orange area. So we can clearly see the dimensions right now. The length of the rectangle is 26 centimeters. That's the bigger rectangle or outer rectangle. The width or breadth of the outer rectangle is 18 centimeters. And you can see that they did not give us the dimensions of the inner rectangle, but they did give us some dimensions here that you can use to find the length and breadth or length and width of the inner rectangle. Okay, so I am gonna try to bring this question easier for students to understand. Let's see how rectangles are applicable and they exist in real life. So we have a wall socket to put in electrical devices. We have a playing card. We have a tablet here. We have a candy bar. I think this is a chocolate bar. We have a door. We have a calculator. And we have a blackboard, old school there, blackboard. Some more rectangles in real life. We have notebooks, a phone, a remote, another candy bar, and some rulers. So rectangles are all around us and we really need to know their properties and how to use them. Now, I got this picture because it shows the aerial view of a swimming pool. The aerial view, meaning from the air. And the one student told me that this looks like a drone footage, like a picture taken from a drone. That could definitely be correct. Everyone has a drone now. So we are interested not really in the water or the pool. We are interested in the area around the pool. So basically the walkway. So if you were building a pool and you had to tile it or carpet the area around, that would be the area you're interested in. How are you going to find the area of that? So let's look at the question again. So we're going to look at rectangles entirely here. So first of all, what is a rectangle? So we see here the basic shape of a rectangle. It's easily identifiable. And I labeled it A, B, C, and D. So remember those corners A, B, C, and D. And we're going to look at all the properties of a rectangle. So this video can actually be a sort of revision. Okay, and even if you have not done rectangles before, this will help you to learn all about rectangles. This could be a really good reference video. So we're going to look at that same rectangle. And it says here, rule 1, a rectangle has two pairs of equal opposite parallel sides. So let me read that again. A rectangle has two pairs of equal opposite parallel sides. So we see here some lines are in blue, some lines are in red. Okay, and we're gonna look at those lines. Now, lines AB, that will be this line here. AB, calling it line AB because it runs from A to B. And lines CD, calling it CD because it runs from line C, well, corner C to corner D. Those two lines, AB and CD, are parallel. They never meet and stay the same distance apart. Okay, so parallel lines never meet and stay the same distance apart. Let's look at lines CA and DB. So we have CA and DB in blue. CA running C to A, and line DB running D to B. Those lines are also parallel, and they never meet and stay the same distance apart. So remember, a rectangle has two pairs of equal opposite parallel sides. Let's look at another property of rectangles now. Another property of rectangles would be their 4 right angles. So a rectangle has 4 right angles. Okay, remember that the little corner squares represent right angles on 90 degrees. Again, remember that the little corner squares represent right angles on 90 degrees. If you refer to our YouTube channel, there's another question on angles. Question was asked concerning angles, and I actually went through all the possible angles, including right angles. So you can also use that as some reference. And the thing about it is that if these squares represent 90 degrees, and there are 4 squares in a rectangle, how many degrees are in a rectangle? So each of these squares represent 90 degrees, okay? And there are 4 of them in the rectangle. So your question, you can pause the video and work it out. How many degrees are in a rectangle? You can also write it in the comment section. Okay, how many degrees are in a rectangle? Moving on. Number 3, a rectangle has 2 lines of symmetry. A rectangle has 2 lines of symmetry. So on our rectangle here, we see 2 lines. Well, each of these lines can cut the rectangle in half. So if we study lines of symmetry, we recall a line of symmetry is a line that cuts a shape exactly in half. This means that if you were to fold the shape, you cut a rectangle out of some paper and you fold the shape along the line, both halves would match exactly. Okay, so sometimes you're doing your artwork and you need to cut things or fold things. When you fold something directly in the center and you fold it over and it cuts it exactly in half, that's a line of symmetry. So again, a rectangle has 2 lines of symmetry. Going vertically up, okay, vertically up, sorry, and horizontally, side to side. So vertically runs up, down, horizontally goes side to side. Let's look at another property of rectangles. A rectangle has two diagonal lines. A rectangle has two diagonal lines. So diagonal lines connect two corners in a shape. So this straight line, diagonal lines are straight lines, connects C and B. And this red line here connects A and D. So a rectangle has two diagonal lines or pair of diagonal lines. Wonderful. Let us go now to look at the perimeter of a rectangle, which is really, really important. Okay, so the perimeter of a rectangle is length plus breadth plus breadth. Now, this is our same rectangle, guys. And as you can see, I just outlined the perimeter in purple. So it is called the distance around the shape. The perimeter is the distance around a shape. So it's, let's say, for example, you were to walk around the shape, you were to walk around the perimeter of shape, you will be walking around the shape, right? Exactly around. You're not stepping into the shape, but only around the shape. So that formula again would be length plus length. Let's say the lines AB plus the lines CD plus breadth, which would be the lines CA and DB. So you just add up all those lines and you get a perimeter. Now, some people call the perimeter, well, some people call the side the breadth, and some people call the side the width. It's the same thing. So it depends. Some people call it breadth, some people call it width, B-R-E-A-D-T-H or W-I-D-T-H. It's the same thing. So if you're using width, it will be length plus width plus width. Now you can also calculate the perimeter in this way. It says 2 multiplied by combination length plus breadth. Okay? Or it could be 2 combination length plus width. Okay, so what I do for this formula here, right? You add A, B, you find the distance here of the length here, that's one length, and you add that to the distance of one breadth or one width, and then you multiply it by 2, because you'll be adding this, you find that, and then you multiply by 2 because you want to find the second one here. And that will give you your perimeter. Okay, so you can use both formulas. You can use length plus breadth, or width plus width, or 2 multiplied by length plus breadth. Okay, notice that you write this formula in brackets. So you find the combination first, you add them together first, then you multiply. Great. So let's look at the area of a rectangle. Now notice that for the perimeter, it was the distance around, so the around outlined the purple color. But the purple color is now completely covering the rectangle. You see that? So what is area? Well, area is the total space covered inside a shape. The perimeter was outside, but we're thinking about inside now. Note that width and breadth mean the same thing, so it can be length multiplied by W, okay? So the area is the total space covered inside the shape. We're not going outside, we're staying inside, okay? So we're covering all the area inside the shape, okay? And this formula is length multiplied by breadth. This formula is length multiplied by breadth. So you'd multiply the distance of AB and BD, okay? You can also say if you use width, length multiplied by W, it's the same thing. So now that we have looked at these properties, let us now look at an example, okay? So this example shows me a rectangle, and the rectangle, the length of this rectangle is 10 centimeters, okay? And the width or breadth of this rectangle is 5 centimeters. So I simply state my formula the area of a rectangle is length by breadth. Okay, I state my formula, always state our formula. Then I put in my numbers now. So my length would be equal to 10 centimeters. My breadth would be equal to 5 centimeters. And now my area is going to be 10 centimeters multiplied by 5 centimeters. So this is my work in here. So my numbers 10 multiplied by 5, 10 multiplied by 5 will give me 50. But guys, I'm also thinking about it like this. You can think about it like this. I'm also multiplying my units. Centimeters multiplied by centimeters would give me square centimeters. Again, centimeters multiplied by centimeters would give me square centimeters. And when you are writing area, you must include square units. Area always uses square units. Okay? You must have centimeter squared or meter squared or whatever unit squared. Always remember to put that 2, that small 2, okay, superscript 2, that small 2 up there to show that it is area and your answer is in square units. Now let's look at our question. Let's look at our question again. So just to recap, we have a long side being 26 centimeters and the length, well, the breadth or the width, okay, the breadth or the width is 18 centimeters. Okay, they did not give us the dimensions of the smaller rectangle, but they did give us some markings here. Okay, and we can find the dimensions of the smaller rectangle or the inner rectangle. Recall our example with the pool. It's like we want to calculate the area of the walking area. You want to calculate the area of the walking area. So if you were to put down some tiles or some carpets around the pool, that's what you're interested in. You're not really interested in going into the pool. It's the area around or the area, shaded area, according to the question, the orange part, according to the question, the orange part. Okay. Great. So recall that there are 2 rectangles, an outer and an inner. There are 2 rectangles, an outer rectangle and an inner rectangle. So the outer rectangle would be the length here of the orange here. An inner one would be this one here. The white rectangle is the inner rectangle. The orange rectangle is the outer rectangle. Okay, so there are 2 rectangles. The bigger one is called the outer, and the smaller one is called the inner. Okay. So let's look at the steps on how to find out this question. Okay. So step 1, we need to find the area of the outer rectangle. Okay. We want to find the area of the outer rectangle. So let's do that. Let's do step 1. So step 1, it says, first of all, let's write the formula. The area of a rectangle, the area of any rectangle is length multiplied by breadth. Length multiplied by breadth. The area of the outer rectangle is, well, they gave us the length of the outer rectangle. That's 26 centimeters. They also gave us the breadth of the outer rectangle, 18 centimeters. So we can now calculate, okay, using long multiplication, 26 centimeters multiplied by 18 centimeters would give me 468 centimeters squared. Okay, so 26, if you do your long multiplication, 26 multiplied by 18 would give me 468, and centimeters multiplied by centimeter would give me centimeters squared. So I have now completed step 1, which says find the area of the outer rectangle. Good. Let's do step 2. Well, step 2 says find the area of the inner rectangle. Find the area of the inner rectangle. Well, how do we do that? Let's see how we could do that. Well, first of all, you state your formula. The area of a rectangle is length multiplied by breadth, and the area of the inner rectangle is length centimeters, unknown to us, multiplied by b centimeters, unknown to us. So let's now figure out what would be the length and breadth or length and width of the inner rectangle. So think about it like this, guys. If you were to walk along the length of the outer rectangle, you would be walking 26 centimeters. Okay? You're going to be walking 26 centimeters. But the question gave us some clues here. It says the length from this point here to this point is 3 centimeters. This point is 3 centimeters. Okay? And the length from this point to this point is 3 centimeters. This is 3 centimeters here. So I want to find, right, the distance of this length. The distance of this length. Okay? So I want to remove, some students said shave off. Okay, I'll use that term. So I want to shave off this extra 3 centimeters here. I don't want that. I only want this length. That's the length of my white rectangle, the inner rectangle. I want to shave off this 3 centimeters here. So it's going to be 26, take away this 3, as well as 26, take away this 3. Okay, because this line and this line would be the same, but I just want this length here of my inner rectangle. Okay, so I'm gonna shave off this extra 3 on the right side and this extra 3 on the left side. So let's look at that in red. So the length of my inner rectangle is going to be 26 centimeters. Shaving off or taking away 3 centimeters. That's this 3 centimeters here. And shaving off or taking away this 3 centimeters here. That's 3 centimeters here. Which would leave me with 20 centimeters. So that's now my length of the inner rectangle. That's the length of my inner rectangle. Okay. And just as we shaved off or removed or took away the extra for the length of the inner rectangle, we can find the breadth of the inner rectangle. So this 18 centimeters here would be the distance of this breadth here. But the question told us that, hey, 3 centimeters are extra on top here, and 3 centimeters are extra below here. So if I just want the breadth of the inner rectangle, which would be my blue line, I just want the distance of my blue line, that's the breadth of my inner rectangle, I'm going to shave off the extra 3 centimeters off the top and shave off the extra 3 centimeters on the bottom. So I'm going to get my calculation as 18 centimeters, take away 3 centimeters off the top, and take away 3 centimeters off the bottom. That's going to leave me with 12 centimeters. Okay, that's leaving me with 12 centimeters. So I've now found the length and breadth of my inner rectangle, smaller rectangle, and I just multiply accordingly. So the area of inner rectangle is equal to 20 centimeters multiplied by 12 centimeters. 20 multiplied by 12 is 240, and centimeters multiplied by centimeters is equal to centimeters squared. I've now found the area of my inner rectangle. And let's go back to step 3. What does step 3 say? Well, step 3 says subtract answer 2 from answer 1. Subtract answer 2 from answer 1. So that means I need to subtract my area of the smaller rectangle from the area of the larger rectangle. Okay, so this is the final calculation. This is the final calculation. So I state the rule, subtract answer 2 from answer 1. So I state the area of my outer rectangle. Area of outer rectangle is equal to 468 centimeters squared. Area of inner rectangle is equal to 240 centimeters squared. I find the difference, meaning I find the answer when I take them away, okay? And I get 468, take away or minus or subtract 240, leaves me with 228 centimeters squared. So the area of the shaded region is equal to 228 centimeters squared. So the orange part or the shaded part of the question, that area is equal to 228 centimeters squared. And that's it. That is the answer to our question. So in a real life situation, I would find the area around the pool in this way. I find the area of the outer rectangle, and I take away the area of the inner rectangle from that outer rectangle, and that's gonna leave me with the area around the inner rectangle. Okay. Great. So let's remember some notes here. You can take these notes down in your book. Number one, parallel lines are lines that never meet. They are always the same distance apart. Number two, a rectangle has two pairs of equal opposite parallel sides. Number three, a rectangle has 360 degrees. That was actually the answer to a question given within the video earlier before, where we saw those four little squares on the corners of the rectangle. Number four, a rectangle has two lines of symmetry and two diagonal lines. Okay. Number five, the perimeter of a rectangle is length plus breadth, or 2 multiply the combination of, or the sum of length plus breadth. And finally, the area of a rectangle is length multiplied by breadth. You guys? So I'm giving you some practice questions, some questions to practice. So we have practice question 1 of 3. So you can pause the video right now. You can pause the video right now and calculate the area of the shaded area. So you need to calculate the area of the pink in the shape. Okay? So you can pause the video and do that right now. Okay? Practice question 2 of 3. We have some new dimensions. You need to calculate the area of the green area. Okay, the green area. Pause the video and calculate that now. You can write your answers in the comments or you can send it to me. You can WhatsApp it to me. Okay. And finally, question 3 of 3. We have to calculate the area of the brown portion. So you can write your answer in the comments or send it to me, WhatsApp it to me, and let me know how this was for you. And please remember that when you are writing the answers for your areas, they must be in square units. Okay, so all these answers must be done in centimeters squared. Wonderful. So this has been another episode of Mathematics Masterclass, the Question Isolate series. I hope that this was beneficial and helpful towards you. And if you need more information, you can call 1-868. That would be the Trinidadian number, 1-868-713-6860. And you can also WhatsApp 1-868-319-6052. That number is 1-868-319-6052. You can also email primaryschoolmasterclass@yahoo.com and find us on Facebook, Instagram, and TikTok. So I hope and I trust that this was very, very beneficial to you. Have a blessed day, everyone. God bless you richly.